Scott.
Thank you very much, Nicole. It really is a pleasure to get to this point in the mission preparation where we spend some time with you all talking about the mission and introducing ourselves. We've been assigned for nearly 2 years now. We got assigned October 31st back in 2006. We've been training full-time for roughly a year since July of last year. So we've had a lot of time to work together to get ready. And over that amount of time, the last 2 years, and especially the last 1 year, working full-time, getting ready for the mission, I can tell you now we are ready to go. We have more work to do in the last 30 days, but I definitely feel that the crew has come together. Everybody knows their jobs, and we're ready to execute it and looking forward to heading down to the Cape, launching, and getting to work on the telescope. So it really is an honor to be here, and we're thrilled to be at this point in our timeline. I'd like to spend a couple of minutes introducing the crew, and I'll just kind of go down the line. We're in the flight order. So next to me is my pilot, Greg Johnson. He's also a Navy pilot. His call sign is Ray J. If anybody remembers the old commercials, you can figure out where that came from. But he grew up in Seattle, went to the University of Washington, studied aeronautical engineering, and then went to test pilot school, although he did go to Air Force test pilot school out at Edwards versus the Navy test pilot school in Pax River, where I went. And worked for NASA for a while before coming in the class of '98. This is his first flight to space. As the pilot, he backs me up on all the procedures on the flight deck and then assists during the flow of the flight, keeping everything going, making sure the shuttle stays healthy, and backing me up. He also is my lead for the IMAX procedures that we're doing, the ICBC, the IMAX 3D movie that will be made after the flight. So he's a great guy to have on board. Next to him is my MS-1, Mike Good. Mike grew up in Ohio. Went to the University of Notre Dame, where he got both his bachelor's and his master's in aero engineering, and then joined the Air Force, flying as a flight test engineer and later as a navigator in F-111s before going to, again, Air Force test pilot school. Came out of there, worked a little bit on the B-2, some on the F-15, and joined NASA. This is his first flight in space. Mike is on the flight deck with me for Ascent as one of my mission specialists who help manage all the tasks that we have going uphill and keeping track of malfunctions, keeping us on the timeline. One of the hardest working people on the flight deck, managing all that. And then once we're in orbit, he performs 2 spacewalks, 2 EVAs, going out with Mike Massimino as part of a team with one experienced spacewalker and one new spacewalker. Next to him is my MS-2, Megan MacArthur. Megan grew up in California, studied aeronautical engineering at UCLA before going to the University of California, San Diego, the Scripps Institute of Oceanography, to get her master's and PhD in oceanography. So she balances both oceans, aeronautic as well as the ocean, and is a great asset to have on board as a result. This is her first flight. She is my prime robotics operator during all the EVAs, the person we look to for moving everyone around on the end of the robotic arm, as well as being my MS-2, the flight engineer for Ascent, who follows along through all the procedures and keeps me on and Ray J on track by being the quarterback of everything we do, calling the plays, getting an agreement with Megan that we're headed down the right path, so she doesn't have to motivate us with the swizzle stick that she has there as we're going uphill. Next to her is an old friend from my previous trip to the Hubble, John Grunsfeld, actually making his 5th flight into space. 3 of those, this will be the 3rd trip to visit Hubble. And John is the lead for all of our EVA activity. He's helped put together all the tasks and timelines and worked with that, helped us both training himself and the rest of us in what we're doing and coming up with optimal ways to get things done. He grew up in Chicago, went to MIT for his undergraduate, and then came back to Chicago, to the University of Chicago, for his graduate degrees in physics and astronomy. He's worked with projects at NASA, flown experiments, and now is basically our lead astronomer on the flight, who has a payload coming for Hubble after the flight, hopefully using the results of his work if we all perform as well as we hope. Next to him is the other veteran from the last flight to Hubble, Mike Massimino. Mike's making his second flight. He grew up in New York, Franklin Square, went to Columbia, and then MIT for his graduate degrees in mechanical engineering. He's making 2 spacewalks this time, leading his team with Mike Good going out the door with him for those. Has worked robotics in our office and also was involved in the robotic Hubble repair mission, and has taken some of the things he learned doing that to make it possible for us to be more efficient in the tasks that we have on this mission. Next to him is Drew Feustel, making his first space flight. Drew grew up in Michigan, went to Purdue, got a degree in geophysics, then got his doctorate from the Queen's University in Canada. He also met a Canadian at Purdue and moved back to Canada with her, and now has brought her to Houston, where he worked for Exxon for a while before coming to NASA to fly. And he'll be doing 3 EVAs along with John Grunsfeld as part of his team. That's our crew. I think you know what we're trying to do to the Hubble from the other briefings that you've received, and I'd like to turn it back over to you all for your questions, and we'll see what you'd like to talk about.
Okay, with that, we'll start with some questions. We'll start on this side. Let's see. Go ahead.
Bill Harwood, CBS News. I guess for John and Mike Massimino, either one, both of you, ACS and STS repairs, we've been told, is pretty complicated. Obviously it is, watching you guys in the tank and the captive fastener captive device and all of that. Can you walk through that with us a little bit and tell us what makes that challenging, what makes that difficult, how it compares, John, perhaps with PCU from the last flight, and just in terms of overall complexity? I mean, I'm assuming those are the 2 items we should really focus on in that context.
Sure. Let me talk a little bit about the advanced camera for surveys repair, and then I'll hand the Space Telescope Imaging Spectrometer repair over to Mass. The last mission, STS-109, we had the task, the power control unit, which was changing out a large box that had an enormous number of connectors around the outside. And it was considered new ground for spacewalking for EVA because we'd never done that many connectors in a short timeline where the balance of the telescope relied on us successfully finishing that repair in a short time, i.e., if we weren't successful, we'd lose the telescope. And we talked about that in the framework of heart surgery on Hubble. You know, this was a critical element for the safety of Hubble, and we had to make it work. We trained very hard on that and used standard tools for the most part, practicing over and over and over again until it became somewhat routine. I think the big difference between that repair and what Massimino and I will be doing on this flight with Drew and Mike Good outside is that we're entering a realm where these devices, advanced camera for surveys, ACS and STS, were not meant to be repaired anything like the way that we're doing it. The tools that we've had to develop, a whole new class of tools for spacewalking, a new power tool, a mini power tool we call it, a cutter, a special grid cutter to cut an EMI grid, you know, essentially 12 very sharp knives that, like a guillotine, will cut an aluminum frame, our fastener capture plates, little bits to take out these tiny screws. All of these tools are brand new for spacewalking. In addition, we're going inside of the instruments. Usually you design spacewalking tools and instruments on Hubble or various orbital replacement units on the International Space Station to have large bolts, big handles. You know, you turn a bolt, you pull something out. We're really going inside the instruments, pulling out circuit cards. These areas are very sensitive to electrostatic discharge. You know, if we get a little spark, you know, the whole thing can be over because we'd ruin the instrument. They are working instruments. They just have some failed components. So we're going in and changing out these components. Going through the repair for the advanced camera for surveys, basically I have to cut an electromagnetic grid off. It's kind of like a screen, metal screen. You may have heard about that this morning. Then I have to remove number 4 fasteners, these tiny little torque set screws. I have 32 of those plus a few other screws to remove a cover plate. Then I have to pull 4 circuit cards out. And then we're going to replace that electronics with new electronics. Instead of putting cards back, we're just going to put a big box in and a new power supply. And I'll be doing that with Drew Feustel on EVA 3. Our goal is to finish that complete in one EVA. We have another EVA, part of an EVA on EVA 5 to complete it if we're not all done on EVA 3. The challenge for me, of course, is doing all those tasks, but in addition, the location of the electronics box on the ACS is not right in front of me, but it's sort of around a corner. So I'm kind of working, as if I'm underneath the car, trying to remove some screws that I can't see. And some of the screws, in fact, I can't see.